Nursing calculations, managing fractions and decimals in the flow rate formula. Our first problem is that we have an infusion running over 15 minutes, and 50 mils of the infusion is being administered to the patient. We want to calculate the flow rate, and this answer needs to be in mils per hour. Our formula for flow rate is volume divided by time, and we know the volume going into the patient, which is 50 mils of infusion, and we know that it is 15 minutes for the time. But if we keep going here, our answer will clearly be in mils per minutes and not mils per hour. We need to change the 15 minutes to hours, and we do know that 15 minutes is a quarter of an hour. So let's put that in, even though it looks a little strange to have a fraction within a fraction. What this is actually saying is how many quarters are in 50, or what is 50 divided by 1/4? Now you cannot cancel across the division sign, and we cannot divide any numbers here. The next step is to turn the division sign into a multiplication sign and flip the second fraction upside down. So, as you see here, the problem turns into 50 times 4, because the second fraction, the quarter, gets turned upside down. Now there is nothing we can cancel, but we can go ahead and just multiply. 50 times 4 is 200. That's no surprise when you think about it, because there are 4 quarters in every one, and we have 50 of them. So 50, how many quarters, would be 50 times 4. And the mils unit is still on the top, and the hours are in the denominator. This time we have a similar problem, but the infusion this time is administered over 45 minutes. Once again, we need the formula flow rate equals volume over time. Once again, the volume is 50 mils, and in this problem, the time is 45 minutes. Once again, we need to change the minutes to hours. Similar to last time, we can change the 45 minutes to 3/4 of an hour. This looks a little bit more complicated, but we treat it the same way. It is really saying 50 mils divided by 3/4 of an hour. Like last time, we changed the division sign to times and flipped the second fraction. 3/4 upside down is 4/3. We can try to cancel if we can, but 3 does not divide nicely into 50, so we just multiply through. 50 multiplied by 4 makes 200, and then divide this by 3. It comes down to a decimal of 66.6 recurring, which can be rounded to 66.7 mils per hour. And if you want to round it to the nearest whole mil, then it will be 67 mils per hour. We have the same problem as we had in the first slide, where we have 50 ml infusion running over 15 minutes again. Once again, we need to turn the 15 minutes into hours, but this time we will not use fractions, we'll use a decimal. And 15 minutes is a quarter of an hour, and a quarter, as a decimal, is 0.25. Now, decimals within fractions do not work very well, but what you can do is turn that fraction into an equivalent fraction. That means a fraction that reduces down to the same thing, but the numbers inside it are proportionally bigger. We just need to use numbers that are not complicated with a decimal point. Here's how we do it. If we jump that annoying decimal point to the right in the 0.25, it is okay as long as we increase the numerator in the same way. That is, we jump the decimal points in both numbers. That will give us 500 over 2.5, which is still difficult, so let's move it another place to the right. And what you do to the denominator, you must do the same to the numerator. And that will give us 5,000 over 25. This is equivalent, the numbers are bigger, but the fraction overall comes down to the same thing that we started with. And most importantly, we are now dealing with only whole numbers within our fraction. So 5,000 mils divided by 25 hours. This is a straightforward long division. 5,000 divided by 25 equals 200. And, as we expected, the answer is 200 mils per hour. In the next chapter, we will be looking at part 9 of nursing calculations, drop factor, converting between millilitres and drops.